Something that shows up frequently in plants are spirals. From the petals, seeds, and leaves around a stem, spirals are everywhere. But what if we actually counted them? Take the sunflower. There are 55 clockwise spirals and 34 counterclockwise spirals. Take a look at more plants and you'll see the same numbers pop up. But why is this? You might recognize that these numbers are part of the Fibonacci sequence. Let's start with 0 and 1. Then the next number is the sum of the last two numbers. So from this, the next number is 1, then 2, then so on. This is defined by the equation where the next number equals the current number plus the number before that, with the first two numbers being 0 and 1. And if you find the ratio between two consecutive Fibonacci numbers, you'll see as we pick bigger numbers, they approach 1.618. It's referred to as phi, or more commonly, the golden ratio. What does this have to do with plants, though? Plants need water and sunlight to grow, and they get those through leaves, so more leaf exposure equals more growth. Since leaves grow in a spiral, the question becomes, how far apart should they grow to fill up the most space? If they're 1/3 of a full turn apart, it would look something like this, where there are 3 groups of leaves. This doesn't fill up a lot of space, and the leaves below the top 3 would barely get any exposure, and after one full turn, the leaves would just overlap each other. Same with these other fractions. Let's try 1 over a more funkier, irrational number. Going back to phi, if the leaves are 1 over phi of a circle apart, they would never completely overlap each other, therefore filling up the most space. And this results in 2 spirals showing up, one going clockwise and one going counterclockwise. The ratio between these numbers of spirals would approximate phi. Is this property exclusive to Fibonacci numbers? Not really. Some plants show Lucas numbers, where instead of starting with 0 and 1, Lucas numbers start with 2 and 1, and then you keep adding them up. In fact, you can pick any two numbers, and if you keep adding up the last two numbers to create a sequence, the ratio of any two successive numbers will approach phi. Why is this? Let's say we have a sequence where the ratio of two successive numbers approaches the same thing. The ratio of xn to xn minus 1 should equal to the ratio of xn minus 1 to xn minus 2. Let's call this number question mark. We can substitute in the definition here, simplify to get this. And the second part is the same as 1 over question mark. We can turn this into a quadratic equation problem to get one of the solutions, 1 plus the square root of 5 divided by 2, which equals phi. So the Fibonacci sequence isn't really unique. It's part of an infinite family of sequences that are related to the golden ratio. This is why plant spirals have shown numbers that come from these other sequences as well. And this kind of just shows how irrational and weird phi is. We can keep substituting in phi here to get this continued fraction, which just kind of neatly slips in between the simple fractions. We don't completely have the details of how plant organs grow into such intricate patterns at the molecular level, but I think it's just so cool how complex spirals in nature and a simple number sequence show that math and biology are more connected than we think.